Okay, the picture that you have in your hand is, as we said, is the moon. It's hard to believe that this moon is the same moon we see at night, and the same moon that astronauts have walked on. But through these moonwalks, we've gotten first-hand information about what the moon's surface looks like. And though few of us will get the opportunity ourselves to see this in person, well, although who knows, what this talk will do, or I'd like to do, is familiarize you in some detail with the features, the surface features of the surface of the near side of the moon, the side closest to us, and to give you an idea of what you would see and feel if you were on that surface of the moon. And the near side is that side which is perpetually turned towards the Earth. Okay, so there are different features for each side, but I'm going to talk about the near side of the moon, and I'm going to use a bit of subject-specific vocabulary that you really won't hear about unless you're talking about the features of the moon, because they're specific for that. So I'd like you to listen for that and make sure you get those. Okay, if you were on the moon, the most distinctive things that you would see, and the most apparent things that you would see, would be the differences between the highlands and the lowlands. Okay? And these flat lowlands, and I'll talk about each one separately, but the flat lowlands are called mare, M-A-R-E, mare, and that's the singular form. The plural form is Maria, spelled like the name, but pronounced differently. M-A-R-I-A. Maria. And these are the flat lowlands. The highlands would be what we call here mountain ranges. Okay, these lowlands or Maria are called seas. Maria means seas in Latin. But don't imagine any oceans or great bodies of water on the moon. They're not there. So remember, they mean seas, but we're not talking about oceans or rivers or lakes or even puddles. And I'm going to come back to this issue of water on the moon later because, well, recent moon explorations have raised questions and possibilities in this area. Anyway, I'll talk about that in a minute. First, what do the lowlands look like? Well, they're very smooth, or fairly smooth, and they include valleys and basins that were filled in with molten lava at some stage in the moon's evolution. And most of the rock in these maria is basalt. B-A-S-A-L-T. Basalt. And basalt rock, if you don't know, is a rock that's found on the Earth as well, and it's a rock that is an igneous rock, a rock that is made of molten lava. Molten lava is melted rock from volcanic activity. Okay, so these maria are associated with this kind of molten lava. This rock, now there are specific types of maria called mascons. M-A-S-C-O-N-S. Mascons. These are a certain type of maria. And what happened is, when spacecraft flew over these mascons, they found that the gravitational pull was much stronger than usual, and these mascons are extremely dense portions of the maria. Okay, there's a high concentration of mass in these mascons. And if you look at the picture, in fact, I think you can see some differences. Where's my picture here? Here it is. So if you look at the dark areas, these are the maria. And the darkest dark in the dark areas are the mascons. Okay? You can't see the mascons very clearly in this picture, but you can see some shadows. Okay? The darkest parts are the mascons. The dark parts are the maria. And all these areas that are lighter are the highlands. Okay, how big are the maria? The circular maria, which are mostly associated with mascons, can range in diameter up to 702 miles, and irregular maria are even larger. What about the Highlands? As you can see from the picture, there's definitely a difference. The Highlands appear lighter in color and brighter than the Maria. And if you were on or in the Highlands, you would see that they are dominated by craters. And a crater, if you've ever seen a volcano, is the part of the volcano, the hole from which the lava had erupted. Okay, so the Highlands are dominated by these craters. And these craters range in size up to 150 miles across. The Highlands may extend for hundreds of miles, and they reach heights of over 3¼ miles. Heights similar to some of our tallest mountains here on Earth. 3¼ miles above the level of the Maria. Okay, now, just a minute ago I said I'd talk about the issue of water on the moon. Very interesting. Until recently, the past few years, scientists were generally unanimous in their belief that the moon was devoid of water. And this stems from the belief that since the moon lacks an atmosphere, it could not possibly maintain water, liquid water, on its surface, because it is because of the Earth's atmosphere, the pressure created by the Earth's atmosphere, that we, here on Earth, can have liquid water on our surface. But the moon has no atmosphere, so therefore no surface water. But in 1998, an unmanned lunar probe sent data to the Earth indicating the possibility of ice crystals, frozen water, permanently frozen water, not liquid, embedded deep in craters on the moon at the lunar poles, and sprinkled sparsely just at the north and south poles of the moon. So we're not talking about glaciers or ice sheets. We're talking about sprinklings of ice crystals mixed in the rocky soil of the moon in very low concentrations. Still, this discovery has people excited because it provides the basic components of rocket fuel on the moon's surface. A lunar refueling station. Though, for the most part, scientists believe this data requires much more examination. And even if it turns out to be true that there are water crystals on the moon, the ability to mine and use that water is still, shall we say, light years away. Anyway, a very exciting possibility with enormous potential. So what would you see if you were on the surface of the moon? What would you feel? Well, there are drastic temperature changes on the moon, okay? Because, again, the moon has no atmosphere, so there's no blanket to keep heat in or to protect the surface from these extremes in heat when the sun goes down, heat and cold, so there are drastic temperature changes. Temperatures on the moon range from 215 degrees Fahrenheit when it's directly under the sun. 215 degrees Fahrenheit. Well, what's that in centigrade? About 102 degrees. And I'd hate to live under that. And it ranges to minus 285 degrees Fahrenheit when it's at its coldest point. Minus 285 degrees. That's equal to minus 176 degrees centigrade. Okay, and this could all be in the passage of one day. These extremes in temperature. And as I said, these wide variations in temperature could only occur on a body that is devoid of atmosphere. And our Earth's atmosphere provides a moderating blanket for us. Okay, another very interesting thing that you'd probably notice if you were on the surface of the moon is that there's no twilight and dawn. We think of twilight, we think of dawn as these periods when we can watch the transition between day and night, okay? But on the moon there's no atmosphere to reflect light. And so there is very little switching time, okay? You might see a little bit of reflection, but on the whole, when the sun rises or goes down, darkness and light would be immediate, except for a very, very small number of reflections from some nearby peaks over the observer's head, okay? But you wouldn't have that feeling of twilight and dawn, which is a lengthy period of time on Earth, because of the reflection of light on the Earth's surface. Okay, in this short lecture, I tried to give you a little bit of a feeling of what it would be like to either be on the moon's surface or be an observer. The moon is 238,600 miles away, and chances are slim that we ourselves will visit, but through the research of astronomers and some of the work of astronauts, we're able to at least visit in our minds.